morning, everyone. Can you hear me? Am I audible, students? Okay, good morning. Okay, so 25 students have joined. We can start actually. It's 9:20. Can you see my screen?
Yes, ma'am.
Okay. So anyone remember last class up to where we completed? Did we complete? I think we have started total solids and suspended
Uh,
solids, right? Chemical characteristics. I think I
yeah,
have started.
no, ma'am.
pH
We haven't started.
pH chemical characteristics I haven't started. Okay, okay. Then this one physical.
We did
Up to
till specific specific connectivity of water.
okay, specific conductivity of water. Okay, I have done with section B. That means that's why. Okay, then today physical characteristics we have completed. Okay, so today we will learn about your chemical characteristics of water. Okay, so you see here. So there are many chemical characteristics. Okay, similarly, like your physical characteristics, we need to test the chemical characteristics. We need to measure the chemical characteristics of water also. Okay, so what things are present chemically? So there are many. Okay, like you can see here. See the total solids, suspended solids, pH value, hardness, chloride content, nitrogen content, iron, manganese. All these are, these are all your chemical characteristics of water. We need to measure how much these chemicals are present in the water. Okay, so these all these we will discuss in our coming this one. Okay, so first one is your total solids and suspended solids. Okay, you see what is total solids and suspended solids. So basically, under your total solids, two kind of solids are present. One is your suspended solids, and the other one is your dissolved solids. So in your water, when you take a water sample of water from anywhere, okay. So if you see it, very nicely under your light or under the sunlight, you can see some substances. Okay, those are floating above the water. Okay, some small minute substances you can see, they are, floating above the water. So all those are your solids. Okay, you can say total solids or you can say suspended solids also. So there are, you can say, some ways to measure the total solids or the suspended solids. So we have some practical, when you will do the lab, there are some ways how to find out the total solids and your suspended solids. Okay, so your to find the total solids, what we do is that we take a beaker. Okay, we take an empty beaker, you can say, and let me, I will try to draw. You are taking a empty beaker, okay? The weight is what? W1. You have weighted the beaker and the weight is W1. Now, in that beaker, what you do is that you pour that sample of water that you have with you. Okay, suppose you have poured VmL of sample of water in that beaker. Okay, and now you weight it again. Okay, so the weight is, suppose it is W2. Okay, and now what you do is that you heat this beaker. Okay, you heat this beaker at, you say, around 105 to 110 degrees Celsius. Okay, 110 degrees Celsius. Okay, so you have taken an empty beaker, you have weighted it, then you have poured a VmL of sample of water, then you heat that sample of water, okay, at 105 to 110 degrees Celsius. Okay, so what will happen in the next step? The water, it will evaporate, isn't it? And some residues will be left at your bottom. Okay, sorry, it went. Okay, let me just tell by your this one explaining. So, what will happen if you heat that sample of water? That after heating, only the residues will left. Okay, and that residues is nothing but your total solids. Okay, so likewise, you can find the suspended solids also. Okay, for total solids, what we did, we just evaporated by heating the water sample directly. Okay, then there is a certain formula. Using that formula, if you can find out the total solids directly. Okay, and the procedure is that one, that you have to evaporate the water. Now, for suspended solids, what we need to do, you need a filter paper. Okay, a filter paper that has a very minute pores. Okay, so that it can retain your residues. Okay, so you have taken a filter paper, a dry filter paper, then you wait, first you wait that dry filter paper, then in that filter paper again you have poured VmL of water in that filter paper. Then what will happen, you the filter paper, obviously it will be wet now, and you now wait the filter paper again. Okay, now after that you let the filter paper dry. uh, Either you can heat it, not heat, sorry, either you can not put it in an incubator, or yeah, you can place it for 24 hours to let it dry. Okay, so after drying, the residues, obviously the residues will be present in that filter paper. So now again you need to weigh that filter paper. So now the weight will be obviously filter paper plus the residues. Okay, residues, or you can say the suspended solids. Okay, then again we have some formula. If you put in that formula, if you minus it, both the no W3 minus W2, you will get your suspended solids. In this way we can find the total solids and the suspended solids. And now we have one, like you see here, I will write here. So total solids is what? It is your, suspended solids, the solids which remain suspended. Okay, and addition of your dissolved solids, the solids which are dissolved in water. Okay, that you can see. So total solids is the summation of your suspended solids and your dissolved solids. So now you can find the total solids. Just now we have told we need to evaporate the sample of water, and suspended solids also, like using filter paper you have found out the suspended solids. Now you can easily find out the dissolved solids by subtracting your total solids minus suspended solids. Okay, So likewise, you can find out your total solids, suspended solids, and your dissolved solids. So what is the permissible limit for if that amount of total solids or suspended solids are present in water, then you can drink it, okay, because that is a permissible limit and no harm will be caused to you. So that permissible limit is your 500 ppm to 1000 ppm. Okay, you can mark this and you can write from here to here. Okay, later you can write from here to here. Means the, just now I explained the procedure is written clearly in these lines. And also the permissible limit is important. The permissible limit is between 500 ppm and 1000 ppm. Okay, you need to remember this. I hope it is clear. Now next is your Next is your wait. Next is your pH. Okay. So next is your pH. So pH, I know everyone knows from your school only. Yes. So pH, everyone knows that pH. It is what it gives us the whether the sample is alkaline or the sample is acidic. Okay, if you are given a water sample, then pH, if you measure the pH and you have got certain value, there are certain values. So reading that values, you can say that the pH of this water is this much, and so the water is acidic, or the pH of the water is this much and the water is basic, or the water is alkaline. Okay, so the definition you see here, it is the pH value of water indicates the logarithm of reciprocal of hydrogen ion concentration present in water. That means there is a certain formula. Okay, formula for your pH. What is the formula? Let us see. pH is your minus log of H plus ion. Okay, pH is your minus log of H plus ion. So it is giving the definition. Okay, so it indicates the logarithm of the reciprocal. So reciprocal, but I am writing here H plus, so this negative sign is coming. Okay, you can say negative logarithm of H plus ion, or the logarithm of reciprocal of hydrogen ion concentration. That means if the H plus value, hydrogen ion concentration in your water, it increases, then obviously from the formula, the pH value of water will decrease. Okay, it is just the opposite. If your pH, if your H plus value, it is, it is decreasing, then your pH value, it will increase. Okay, so this formula says that thing. Okay, so basically we have one scale for pH. You can say the scale is 0 to 14. Okay, 0 to 14 scale we have, and in between we have 7. So when the pH, it is between your 0 to 7, the water sample, it is said to be acidic. Okay, and when the pH value, it ranges from your 7 to 14, the water is said to be alkaline. Okay, the water is said to be alkaline or basic. Okay, and when the water sample, it has a value of 7, the water sample, the pH value of the water sample is said to be neutral. Okay, so this is the scale for your pH value, for finding out the pH value. So if I say that the water sample, it has a value of 3. Okay, so if a sample has a pH value of 3, that means that sample is your acidic sample. And now if I say that a water sample, it has a pH value of 9, that means that sample is your alkaline sample. It has base. Okay, it has base, so it is alkaline. So and if I say, suppose a water sample, it has a pH value of 7, then it has a neutral pH value. Clear? So the pH value, it is about this much only. Okay, if you know this much, then it's fine. Now there is you know permissible limit for your drinking purposes. Okay, every time now I say that we cannot drink acidic water, or we cannot drink basic or alkaline water. Okay, all we need is that we need a neutral pH value water. But every time it is not possible that the we get a pH 7 value of drinking water. Okay, every time it is not possible that we will get a value of pH value 7. So the government, they have already, they have prescribed some permissible limits for your drinking purposes, so that the public can drink if the pH value range from this to that value. Okay, so what is that value? Let us see. Acha, what lines you can write from here? Um, you can write from here up to here. Okay, from here to here you can write it down. Write it down means now you can take a screenshot, later you write it down. Okay, then you need to write the formula also. Can you write the formula? Just now I have written that formula. Okay, whenever you write something about pH, you should write the formula also. Okay, you can write it down if you forget later. pH is equal to, write it down like your the definition that is given. Log of, okay, you can write it down like this. If you forget, you write down pH is equal to log of reciprocal of H plus ions, or either you can write minus log of H plus ion. Okay, formula you always mention. Please take a screenshot. And one more thing, yes. If your H plus ion is there, that means it is your acidic, okay? And if your, it might be like here, it might be like pH is equal to, pH is equal to, it can be like this also. Minus log of, okay, it can be written like this also. That means, as I said, it gives the indicator of your acidic or your alkaline solutions, whether the solution is acidic or it is alkaline. So whenever it is alkaline, the formula will be this one. Okay, and whenever the solution is acidic, that means your H plus ion is present. If your solution is basic, then your OH negative, that means hydroxyl ions will be present. This one is your hydroxyl ion, and this one is your hydrogen ion, that means your H plus ion. Okay, you remember this much. Then next line you can write as this one. This one you can write from here to here. Take a screenshot. Okay. Now, next let us see about the permissible limits. Wait, let me see this one. Okay, this is the permissible limit. You can write from here to here. So what is the permissible limit you see? Permissible pH value for public supplies may range between 6.6 to 8.5. This is very important that you should remember what is the pH value of your drinking water. If someone asks you like that, you should tell that the permissible limit or the pH value for drinking supplies or public supplies is between your 6.6 to 8.5. And now one question comes that what will happen? Okay, what will happen if suppose we drink a pH value, suppose that is 4. If the water is acidic, and if we drink that water, so what will happen? So okay, that will obviously, it will cause your digestion problems. Okay, digestion problems will happen. And also what will happen is that the pipe or the conduit through which the water it will come, okay, through which the water will come to your the home or to your distribution system. So that pipe, it might cause incrustation. Okay, you see here one word is here, incrustation will happen. Okay, or sorry, if the no acidic, if the water is acidic, then your corrosion will happen. Okay, if it is the water is acidic, then in that pipe your corrosion will happen in that pipe. And if the water is alkaline, it will produce incrustation. That means in your pipe, some means the under the I am talking about the under one. Okay, so what will happen, some white deposits will form. Okay, through which the water is coming in that conduit, in that pipe. Some white deposits or layers of deposits will form, which will result in which what will happen if that white deposits will form. Suppose you are getting the water at a very high velocity, so obviously if the white deposits will form, obviously the cross section of that pipe, okay, the cross section of that pipe, it will reduce. And in order, what will happen if the cross section of the pipe will reduce, obviously the velocity at which you were getting the water previously, you won't get at that velocity. Okay, because the cross section it will reduce. Okay, due to the incrustation is happening. And also what will happen is that the the age of the pipe for which the years, the number of years for which the pipe it is designed, it will not be according to that years. Okay, the pipe, it may it may damage, it may gets damaged before the design period of that pipe. Okay, so all these things will happen if you drink, or if such waters are being supplied to your distribution system. Clear? So your permissible limit is 6.6 to 8.5. You can write this line later. Okay, next is your hardness of water. Okay, so what is hardness of water is that sometimes some water, it will sufficient, you can say, ladder or foam. Okay, it will not form with that water. When you use that water, sufficient formation of foam or sufficient ladder formation will not happen. And that is the characteristics of you, and that is the time when you can say that the water it is hard. Okay, and what why such hardness happens. Okay, you can say, just wait. It is usually caused by the presence of calcium and magnesium salts present in the water. This is an important line. You can write from here itself. Hardness in water is that characteristic which prevents the formation of sufficient ladder or foam when such hard waters are mixed with soap. That means when you mix with soap, obviously we all have seen that whenever we mix soap and water, sufficient foams are happening. So that means that that water is not your hard water. Okay, so whenever such foams or ladder formation is not happening when you mix water with your soap, that means your water is hard. It can be said that the water is hard. And what causes your hardness? It is due to the presence of calcium and magnesium salts present in water. Clear? So, um, again, if hard waters are present, that will lead to your corrosion and incrustation of pipe. Same thing will happening, making food tasteless, etc. Okay, so then two types of you can say hardness are present. The one is your temporary hardness, and the other one is your permanent hardness. Okay, so let us see what is temporary hardness. It is written here. If bicarbonates and carbonates of calcium and magnesium are present in water, the water is rendered hard temporarily. Okay, so if carbonates and bicarbonates of calcium and magnesium are present, you have to remember this line. Okay, if bicarbonates and carbonates of calcium and magnesium are present, the water is said to be temporarily hard. So what is temporary hardness is that why this name is given, because that hardness of water, temporary hardness of water, it can be removed. Okay, it can be removed by what? By, you can say, boiling the water. If you boil that water, the temporary hardness, it can be removed either by boiling or by adding lime to the water. Okay, if you add lime or if you boil that water, temporary hardness can be removed. Okay, so next let us see what is your permanent hardness. See here, uh, on the other hand, if sulfates, chlorides, and nitrates of calcium or magnesium are present in water, okay, it is known as your permanent or non-carbonate hardness. Okay, so one more thing is, it is there temporary hardness or carbonate hardness. Okay, two names are there, temporary hardness or carbonate hardness, and the second one is your permanent hardness or non-carbonate hardness. Okay, so in your permanent hardness, if sulfates, chlorides, and nitrates of calcium or magnesium salts are present in water, then your water is considered to be permanent hardness. And what it is permanent hardness? Permanent hardness, it can't be removed just by boiling or adding lime to the water. It is not that easy. Okay, we need to go to some other processes, treatment processes are there, like you can say geolite softening is there. Okay, some other processes are there, demineralization is there. So these all these things we will learn later in our treatment of water, we will learn in that chapter. Okay, so basically you need to remember that for your temporary hardness, you carbonates or bicarbonates of calcium and magnesium salts are present. And for your permanent hardness, sulfates, chlorides, and nitrates of calcium or magnesium salts are present. Okay, this much is important to remember. Now, there is one formula to find uh, the total hardness. Okay, this is the formula. This is the formula. You can take a screenshot of this. Okay, you have taken. Okay, next. Just wait. Okay. Okay. So, what is the limit? What is the limit you see? The prescribed hardness limit for public supplies ranges between 75 to 115 ppm. Okay, remember this line, you need to write it down. Okay, 75 to 115 ppm. Here you need to write the limits. Okay, next is your chloride content. Chloride content, you see it's written here. Chlorides are generally present in water in the form of sodium chloride. Everybody knows, yes, common salt is your sodium chloride, and may be due to leaching of marine domestic waste. Okay, so their concentration above 250 milligram per liter produce a noticeably salty taste in drinking water and are thus objectionable. That means if chloride content it is more than 250 milligram per liter, it will impart a salty taste in your drinking water, and that obviously salty drinking water nobody likes to drink. So uh, uh, therefore, above 250 milligram per liter, it is not recommended. Okay, the chloride content it should always be below your 250 ppm. Okay, you see here. So whenever there is a chloride content present in water, you can say that water it is polluted. Okay, that water is polluted either due to sewage, you can say, and or industrial waste. Okay, whenever chloride is present in water or in a river or any stream waters, okay, whenever it is present, you can say that the water is polluted due to sewage and other industrial waste. Okay, and the what it is written, the value it should not exceed your 250 ppm. So that is your permissible limit for the chloride content. Clear? So next, this much these are short notes, you can make it by yourself. Okay, so just you need to write what will happen if chloride content is present, what causes chloride content, or what is the permissible limit. Just 3 4 lines if you write, then it's fine. Okay, no need to write the whole thing, don't need to just memorize all the things. Just you see the important lines and you write it down in your exam. Okay. Next is your next is your nitrogen content. Nitrogen content, you see the presence of nitrogen. Okay, my battery is running low. Okay, you see here, the presence of nitrogen in water is an indication of the presence of the organic matter and may occur in one or more of the following forms. Okay, so if nitrogen is present, that indicates that it has the water sample. It has organic matter in it. Okay, the water sample has organic matter in it, and the nitrogen content, it can be in any of the following four forms. Number one is your free ammonia or ammonia nitrogen. Second is your albuminoid or organic nitrogen. Third is your nitrites, and fourth is your nitrates. Okay, so let us only know the permissible limits. Okay, no need to go in that. Let us just know the permissible limits. So for your free ammonia, ammonia everybody knows. Okay, it has a very bad smell. Ammonia, it has a very bad smell. So first let us see one line. Wait. See this line. The presence of free ammonia in water indicates the start of decomposition of organic matter present in water, and for potable waters, its value should not. Okay, the meeting will end in 5 minutes. Okay, so listen. If the meeting ends, we will again start at 10:15. Okay, you join that at 10:15. I will provide you one new link in your group. Okay, so just using that link, you join at 10:15. You also take a 15 minutes break. Okay, so okay. So the presence of free ammonia, what it indicates? It indicates the, as I say, that nitrogen content means that it says that it indicates that the presence of organic matter, it is there in the water sample. So presence of free ammonia means it will indicate the start of your decomposition of organic matter. Okay, it just indicates the start of decomposition of organic matter present in water, and its value, it should not exceed your 0.15 milligram per liter. Okay, so let's keep it here till now. We will start again at 10:15. Okay, so take a 15 minutes break. I will also take a break, then we will again start. Okay, everyone, I will take the attendance then. Okay, not now. Okay, so I'm ending the meeting here. I will provide you one new link. Okay, you join by that one.